Hello everyone. We're going to be answering the following question. And it states, draw the Lewis structures of boron triiodide, arsenic pentafluoride, and xenon tetrafluoride. So when answering this question, we're going to run into a number of things. This question is going to kind of go over the exceptions to the octet rule. The exceptions to the octet rule are as followed. 1, you can have a central atom that does not have an octet due to the shortage of electrons. 2, and this first one typically happens with your group 2A and 3A atoms. 2, you can have an odd number of electrons, and this will result in a radical, which a radical is just an unpaired electron. And 3 is the central atom has an expanded octet, and this will occur when the n is greater than or equal to 3. And this occurs because you have the d orbital which can participate in bonding. So let's go ahead and determine the number of valence electrons for each of these cases. So for boron triiodide, we have 24 electrons to distribute. So my central atom is boron. I form my skeletal structure, and then I distribute all my electrons. Well, once I do that, I'll get a structure that looks like this, and then this is the correct structure. You will not go ahead and complete the octet for boron, so 2, 4, 6. And the reason why is because this is stable. If you do the formal charges on this, you would end getting a 0 formal charge for boron, whereas if you were to form a double bond, you'd end up getting a negative formal charge. If you did do the double bonds, that's a potential resonance structure. However, this is a more stable representation of this molecule. So for B, we have pentafluoride. So we have arsenic pentafluoride. So we have a total of 40 electrons to distribute. One, 2, 3, 4, 5. So I've distributed each of my fluorine atoms, and I go ahead and complete the Lewis structure by adding my lone pairs. Okay, great. We've distributed the electrons. However, what we note is that arsenic has 2, 4, 6, 8, 10 valence electrons, and this is okay. It's following that expanded octet because it has the d orbitals that it can utilize for bonding. And in the last case, we have C, which is xenon tetrafluoride. Xenon tetrafluoride. Xenon is our central atom. And we'll go ahead and distribute the 4 fluorine atoms. In this case, we have 18 electrons to distribute, so 1, 2, 3, 4. 18 paired electrons to distribute, so 18 times 2 is 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, I have 16. I still have additional electrons to distribute, and the rest goes on xenon itself. 17, 18. And if you go ahead to count each of those, you would have a total of 18 electrons. So these are 3 cases that you could have with the exceptions to the octet rule. It's important to go ahead and practice each scenario that corresponds to each exception. Thank you.